What's up, TUMNAD lectures? In this video, we are looking at what we call the blood flow through the heart. If you find this video helpful at the end of it all, make sure you like the video, comment down in the comment section, and please subscribe. Let's go ahead and get started. In the previous videos, we looked at what we call the anatomy of what we call the heart. Today, we are looking at what we call how the blood is going to be moving through what we call the heart. We're going to be looking at all step by step, all those kind of the area through the heart, where this kind of the blood has to touch as it moves through all the different chambers of what we call the heart. Okay, that's going to be the target of the today's video, all step by step. So now we are going to be using what we call the blue marker to tell that this blood is going to be now deoxygenated, and once the blood becomes oxygenated, we shall use the red marker to signify that this blood is now fully oxygenated. Okay, now we are going to be starting from what we call whenever the blood which is deoxygenated, whenever it comes back to the heart. The question is, what are some of those kind of great vessels that collects the deoxygenated blood and forwards it into what we call the right atrium? And that one is going to be what we call the superior and then the inferior vena cava. So now our first step is what we call all deoxygenated blood enters the heart through what we call the superior and then the inferior vena cava. That is our first step, number one. Step number one is going to be what we call blood coming from what we call superior and what we call inferior vena cava. Okay, so now that's going to be our first step in the study of what we call blood flow through the heart. All the deoxygenated blood from the superior vena cava and then inferior vena cava will converge into what we call the step number two. Okay, step number two. Our step number two is going to be that all that blood which is deoxygenated through superior and then inferior vena cava will enter through this chamber here. You know how this chamber is called? This chamber here is going to be what we call the right atrium. So now our second step is going to be right. It's going to be what we call the right atrium. Okay, so now that one is going to be now our second step of what we call the blood flow. So now the biggest percentage of this deoxygenated blood in the right atrium, the biggest percentage will flow down just by passive mechanism. Then the right atrium will squeeze the remaining kind of the blood to move down into this chamber. But this blood, as it moves down, it has to knock these great structures to open. You know how these structures are called? So now our kind of the third step is going to be these beautiful structures that has to open to allow this blood to move down into this chamber. So now these structures here are what we call the tricuspid valve. Okay, are what we call the tricuspid valve. Now, when the tricuspid valve opens, it will allow now the blood to flow to this area here. So now our fourth step is going to be what we call this chamber here, which we call the right ventricle. Okay, it's going to be what we call the right ventricle. Okay, what we call the right ventricle. So now this blood is still deoxygenated. Okay, now we have started from step number one. This was step number one, and then this one here was step number two. Then this one here was step number three. Then we are on step number four. Okay. Now what happens that this the right ventricle, they are going to be squeezing this blood. Now when they squeeze this blood, it will enter into what we call the pulmonary circulation. But before they enter into the pulmonary circulation, we have these structures that has to open to allow the blood to move off what we call the right ventricle. You know how these structures are called? These structures here are going to be now our fifth kind of the step. Okay, they are going to be our fifth kind of the step, and these structures here are super very important. These structures here are what we call the pulmonary semilunar valve. Okay, are what we call the pulmonary semilunar valve. Okay, so now that's going to be now our fifth step. Then from there, when this the semilunar valve, the pulmonary semilunar valve, when they open, our blood will now move into what we call the pulmonary trunk, and then finally into what we call the pulmonary artery. So now our sixth step is going to be what we call the pulmonary trunk. Okay, so now our sixth step is going to be what we call the pulmonary what we call the pulmonary trunk. So now our sixth step is going to be what we call the pulmonary, what we call the pulmonary trunk. Now what happens is that the pulmonary trunk is going to be dividing into two. It's going to be dividing into what we call the left and then the right pulmonary artery. Okay, what we call the left and the right, pulmonary artery. Okay, so now the whole significance of this kind of the pulmonary trunk, the left and then the right pulmonary artery, that they are delivering deoxygenated blood to one of the beautiful structures. You know how these structures are called? They are going to be taking this blood to our kind of the structures which we are calling the lungs. Okay, so now blood from what we call the right and left pulmonary artery will have to access what we call the lungs. Okay, what we call the lungs. And in the lungs, one of the most beautiful process that we are going to be having in the lungs is going to be what we call gas exchange. Okay, we're going to be having what we call gas. We're going to be having what we call the gas exchange. But the question is, what is that kind of the surface, or what kind of those kind of the blood vessels that are going to be helping in this kind of the exchange? We are going to be having what we call the pulmonary capillaries. Okay, that is something which is super very important, that we are going to be having what we call pulmonary capillaries. Okay, pulmonary capillaries. So now here we are going to be having the pulmonary capillaries that are going to be aiding in the exchange of what we call the out movement of what we call the carbon dioxide into the lungs, and then the in movement of what we call the oxygen to the blood. Okay, so now what are we going to be having here? We are going to be having carbon dioxide gas, carbon dioxide coming out, and then we shall have oxygen entering into the blood. So now in the pulmonary capillaries, we are now having fully oxygen blood. Now what happened is that our blood is now fully oxygenated. Now where else does it go? It is very simple. Now from the pulmonary capillaries, we are going to be now entering into another kind of the tiny kind of the blood vessels which we call the pulmonary venules. Then multiple of the pulmonary venules will come together and they form what we call the pulmonary veins. So now our eighth step is going to be what we call the pulmonary. It's going to be what we call the pulmonary veins. Okay, what we call the pulmonary veins. Okay, so now, and when we talk of the pulmonary veins, these are going to be now the pulmonary veins. This is going to be now our eighth kind of the step. Okay, our seventh step was taking place in what we call the lungs. Okay, and then our eighth step is what we call the pulmonary veins. They are now bringing oxygen-rich blood to these beautiful structures. We have what we call the left pulmonary veins and then the right pulmonary vein. They all pour this blood into this chamber. So now this one here is going to be now our ninth step. Okay. So now it's going to be now our ninth step. So now the question is, how do we call this beautiful kind of the chamber? This chamber here is what we call the left atrium. Super very important. Now, like the right atrium, also the left atrium is going to be allowing, by passive mechanism, the biggest percentage of the blood will flow down what we call another kind of the chamber here. Okay, passive. Then it will contract and push the remaining small percentage to move down. Okay, so now but as this blood moves down, it has to knock these beautiful structures. You know how these beautiful structures are called? These beautiful structures, I'm going to put them like step number 10. Okay, they are going to be like step number 10. So now the question is, how do we call those beautiful kind of the structures? Those beautiful structures, they have a couple of names. They are called the bicuspid valves, the mitral valves, or also the left atrioventricular valves. But the beautiful word here I can use is going to be what we call the bicuspid. They are simply called bicuspid because they are going to be having two kinds of the cusps. And these one here are called the tricuspid because they have three cusps. Okay. However much, the third one is not so much invisible in this diagrammatic illustration. Okay. It is such a beautiful thing. So now, when this blood passes through what we call the bicuspid valve, okay, what we call the bicuspid valve is now going to be entering into this beautiful kind of this chamber. So now this one will give us what we call step number 11. So now our step number 11 is going to be this beautiful chamber. You know how this beautiful chamber is called? This beautiful chamber here is what we call the left, the left ventricle. Okay, is what we call the left ventricle. Now, when you look at the muscular layer of the left ventricle and then the right ventricle, realize they are going to be too much different in the thickness of what we call the myocardium. This one is going to be too thick and this one is going to be too thin. And the significance of this is that this one, the right ventricle, is pushing the blood to a shorter distance, just to the lungs, and then it comes back. But when you come to the left ventricle, it is pushing the blood to a longer distance, to the entire body parts. That's why it has to be too muscular, so that it generates extensive amount of the energy that will push the blood to all over parts of the body. Okay, and then from there, when the left ventricle squeezes like as if it has never squeezed before, it will allow this blood to come and knock these structures here. These structures here are going to be now my step number 12. You know how these structures are called? These structures are super very important. If it wasn't these structures to be friendly by opening, blood wouldn't leave what you call the left ventricle. Okay. In other words, as this left ventricle pumps or contracts, the blood has to knock on these structures. These structures are what we call the aortic semilunar valve. Okay, and what we call the aortic semilunar valve. Okay, now once this aortic semilunar valve opens, it will allow now the blood to move to this is one of the biggest artery in the whole human body. You know how this artery is called? This is going to be now our step number 13. This step number 13 is going to be now the biggest the artery in the human body, and this one here is what we call the aorta. Okay, so now our step number 13 is going to be what we call the aorta. Okay, and then this blood, which is now fully oxygenated, was leaves what we call the aorta. The aorta is going to be supplying all body tissues. Okay, blood from the aorta is going to be supplied to the entire body parts. Okay, so now from there, our last step, which is going to be step number 14, is that this blood, which is fully oxygen from what we call the aorta, will now go to what we call the entire body. Will go to the entire body tissues. Okay, so now that's generally how the blood is going to be passing through what we call the heart. Okay, so having seen all that, let's just have a very quick recap of what we have just said. We said that all the oxygenated blood from the upper and then the lower extremities, they will have to converge into what we call the right atrium, from what we call the superior vena cava and then the inferior vena cava. This blood is deoxygenated. It will enter into what we call the right atrium. The biggest percentage of the blood will move down by passive mechanism. It will squeeze the remaining percentage to move down to this chamber. But before this blood enters in this chamber, we have these structures that have to open. These structures are what we call the tricuspid valve, or what we call the right atrioventricular valve. Once they open, this blood will flow into what we call the right ventricle. This right ventricle will squeeze like as it has never squeezed before, and then this blood will hit these other structures, which we are calling the pulmonary semilunar valve. When this pulmonary semilunar valve opens, the blood will enter into what we call the pulmonary trunk, of which the pulmonary trunk will divide into what we call the right and then the left pulmonary arteries. These arteries are taking the blood to what we call to the lungs. In the lungs, you're going to be having what we call gas exchange on what we call the pulmonary capillaries. The pulmonary capillaries are providing what we call exchange surface for what we call the entry of what we call oxygen and then exit of what we call the carbon dioxide. Okay? Now, after the pulmonary capillaries, you're going to be having now what we call the pulmonary venules, of which multiple of the pulmonary venules will come together and make what we call the pulmonary veins. Now, we're going to be having now the pulmonary veins, which are going to be now carrying fully oxygenated blood into this other the chamber, which we are calling the left atrium. Now, the left atrium will allow the biggest percentage of the blood to flow down to this chamber by passive mechanism. However, before this blood moves down, it has to know these structures here, which we are calling the bicuspid valve. Okay, when the bicuspid valve opens, blood will flow into what we call the left ventricle. The left ventricle is super much muscular, and the significance of this, why it is muscular than the right ventricle, is that this the left ventricle is pushing the blood to a longer distance. You can imagine pushing the blood to a lower body parts. It needs a lot of energy, it needs a lot of muscles which are going to be generating enough extensive force when they contract. What happens that this left ventricle will squeeze like as if they never squeezed before, and will push this blood to knock this kind of these structures which are calling the aortic semilunar valve. These aortic semilunar valve are going to be opening, and then the blood will move into this kind of one of the biggest kind of the artery in the human body. And this artery is what we call the aorta. This aorta is going to be one of the largest distributing kind of the artery that's going to be supplying the entire body parts. We'll give some of the oxygen and nutrient-rich blood to the upper extremities, and then even also give what we call the lower extremities, then what we call the descending aorta. And then all the blood will now go to what we call the entire body tissues. Okay? So now that briefly summarizes what we call the blood flow through the heart. TUMNAD, I have talked a lot of things, and if you think whatever I've talked is making sense, is adding to you, you have enjoyed, please, you guys, you know what to do. Just hit the like button, comment down in the comment section, and please subscribe. Thank you very much for watching TUMNAD as always. Until we meet next time.